Hello everyone, today we're talking about rational functions, intercepts, and asymptotes. So you can see that I've broken section 3.6 into part 1, and then we'll do part 2 at the next class. So today we're just going to cover the intercepts of rational functions and the vertical and horizontal asymptotes of rational functions. Part 2, which will be the next lesson, will cover slant asymptotes, which we'll get to those, and actually sketching the graphs. So let's get into 3.6 part 1. So the first thing I would like us to have down is please copy this chart down. It breaks it down right into how to sketch rational functions. So go ahead, write this down, pause it, write it down, and then also write down this, at least this is complex, but at least write down the vertical asymptotes are the line x equals a, where a is a 0 of the denominator. So that means just solve, set the denominator equal to 0 and solve. That will give us our vertical asymptotes. And then your horizontal asymptotes fall into one of three categories. Either our numerator degree is less than our denominator degree. That's all they're saying here, right? This is the degree of my numerator is the n. The degree of my denominator is an m. You can see it here. So if the numerator degree is less than the denominator degree, then our horizontal asymptote is just the x-axis. It's just the line y equals 0. If the numerator has a larger degree, if the numerator has the same degree as our denominator, well, then the horizontal asymptote is just the ratio of the leading coefficients. Right? So if they have the same degree, if n and m are the same, then that just means the line y equals the ratio of those leading coefficients will be our horizontal asymptote. Then finally, if the numerator has a larger degree than the denominator, then we have no horizontal asymptote, we have a slant asymptote, which we'll get into in the next lesson. So we won't cover this case. As far as today is concerned, if the numerator is larger, we'll just say it has no horizontal asymptote, which it doesn't because it's a slant. So let's go ahead and move on to the first example. So here they want us to find our x, just find the x and y intercepts of the function. So, our chart said, first thing we want to factor the numerator and denominator. That's the first step whenever we're dealing with rational functions. Then we're going to find the x-intercepts by determining the zeros of the numerator. Right, so zeros of the numerator give us the x-intercepts. And we saw zeros of the denominator gave us the vertical asymptote. So you got to keep those separate. Zeros of the numerator here will give us our x-intercepts, and the y-intercept, we just basically plug in 0. So you plug in 0 to your graph wherever you see an x, and that'll be the y-intercept. And then we'll get into vertical and horizontal asymptotes in the next example. So right now, we're only worried about factoring it, if it can be factored, and then find the x and y-intercept. So, it's completely factored. There's no other way we're going to do this. So to find the x-intercept, right, those are the zeros of the denominator. So you set 3x plus 5 equal to 0. Zeros of the numerator. Right? Zeros of the numerator are the x-intercepts. So we set 2x equal to 0. Okay, so x, if you divide both sides by 2, x equals 0. So since x equals 0 is our only x-intercept, that means our x-intercept is the point 0, 0. Right, that's when our numerator, and I even got a little backwards there, our numerator, set the numerator equal to 0, that is going to be our x-intercept. So set it equal to 0, solve, cool. Next one, to find the y-intercept. Okay, we just plug x in, we plug 0 in for x. So if we plug 0 in for x, that gives us 2 times 0 divided by 3 times 0 plus 5. Well, that's going to give us 0 over 5, which is just 0. So that means our y-intercept is also 0, 0. which makes sense, right? Because if it goes through the point 0, 0 as our x-intercept, then that's obviously where it's going to cross the y-intercept too. So it makes sense that the x and y-intercept are only 0, 0, and that is all we had to find here was the x and y-intercept. So a pretty basic example, but just to show you, this rational function will look like this, right? And it goes through the point right here, 0, 0. That's the only time it's going to cross the x-axis. That's the only time it's going to cross. That's the only time it's going to cross the x. Only time it's going to cross the y. We'll see what's happening down at these. These lines are never going to cross. This line here, especially, will never cross the x-axis again. And we'll see why when we get to some more examples. So the next example, they just want us to find the vertical and horizontal asymptotes of the rational function. So again, I go back to my chart on slide 2, and first thing I have to do is factor. So the numerator has an x in common, and that leaves me with x squared minus 9. And the denominator, let's see, has a 3 in common, so that leaves us with x squared minus 2x minus 3. Okay, and then this again factors in the numerator, x times x minus 3, x plus 3, and the denominator factors to x minus 3, x plus 1. Okay, so a unique thing has happened here. So a unique thing has happened here where they're the same factors in the numerator and denominator. So that causes a hole. That causes a hole at the point when x equaled 3. Not zeros, when x equals 3 makes that 0. That's what I was thinking of. So when x equals 3, right, because that's what makes this 0, our function is going to be undefined. There's going to be a hole at that point. So when we get to the graph, I'll show you what that hole means, but let's continue on. So the vertical asymptotes are the zeros of the denominator. So now we're actually dealing with the zeros of the denominator. So that means I set my denominator equal to 0. Okay, so then negative 1 is a vertical asymptote. I'm sorry, not x equals negative 1. Right, because if we set x plus 1 equal to 0, we get x equals negative 1. That is our vertical asymptote. Okay, we're not worried about x minus 3 when we're talking about vertical asymptotes because we canceled it with the numerator there. So the only one we really have to worry about is x plus 1 because we've canceled the x minus 3 in the factoring step. So x minus 1 is our only vertical asymptote. Then to find horizontal asymptote, we just look at our n. So our n is the numerator, our m is the denominator, right? And since the numerator has degree 3, denominator has degree 2, looks just like this. So since the n is larger than the m, no horizontal asymptote. So if I were to say horizontal, we just say none. So x minus 1, very important. Vertical asymptote, no horizontal asymptote. So let me show you what they mean by a vertical asymptote. So this graph, we can see that at negative 1, right, and it's counting, each box is 1/2. So at negative 1, you can see this dotted line here represents the line x equals negative 1, and it's a vertical asymptote, right? My line is going vertical, and this graph is never going to touch that line, just like this part of the graph is never going to touch that line. Right? That's what it means by an asymptote. It's going to approach that line, right? So it's going to approach x equals negative 1, but it's never actually going to cross that, right? This is just going to go on forever towards negative infinity, but never cross the line x equals negative 1. Same thing here. This is going to go towards positive infinity, but never cross the line x equals negative 1. Also, remember that factor that we crossed off? That is why there's a hole here when x equals 3. So if you plugged 3 in, you'd get this point here that it's defined at undefined at x equals 3. And basically you just need to know that x is undefined at 3. If they ask for a holes, asymptotes, intercepts, so you would just say, yep, there's a hole at x equals 3. Next one. They want us to find the vertical and horizontal asymptotes again. So the first thing we're going to do is factor. Well, the numerator is already factored as far as it can go, but we can see that in the denominator there's a 2 in common. So I'm going to pull that out, and I get x minus 4, or x squared minus 4, which is good because then that factors again. 2 times x plus 2, x minus 2. Alright, so that's factored completely. We can see there's no holes because none of them will cross off, none of the factors will cross off. So that means I can go into my vertical asymptote to start. So vertical asymptote, remember, that's the zeros of the denominator. So I'm going to put my factored form in there, because we'd eventually have to factor it out anyway, so as long as it's factored, let's use that to find our vertical asymptotes. 2 does not equal 0, so that's disregarded. So x plus 2 equals 0, x minus 2 equals 0. So our vertical asymptotes is x equals negative 2 and x equals positive 2. So those are going to be vertical lines at negative 2 and positive 2. Then let's find our horizontal asymptote. And since my numerator has a smaller degree than my denominator, right? So if I go back, my numerator is smaller than my denominator, so the horizontal asymptote is just the x-axis, right? It's the line y equals 0. So let's see what that graph looks like. So remember, vertical asymptote, negative 2 and 2. Horizontal asymptote, the line y equals 0, or the x-axis, did the same thing. And you'll see here, you can kind of see in the red dotted line is our horizontal asymptote, so it's just the x-axis. And we have a vertical asymptote at negative 2 and at positive 2. So again, these orange lines will never cross these dotted lines. They're just asymptotes. They're approaching those points without actually touching. And just to reemphasize, today you do not know how, after today, you do not know how to graph them. We'll talk about graphing them in the next lesson. So right now we're just worried about finding these horizontal vertical asymptotes and finding the intercepts, wherever they may be, X and Y intercepts. So this one didn't ask us to find the y-intercept, but most problems will once we get there. And that leads us into the last one, where we want to find, last one, where we want to find all the intercepts, X and Y intercepts, and then all the asymptotes. So vertical and horizontal asymptotes. First thing you want to do in every single one of these rational functions problem is to factor. So we get x plus 3, x minus 2. That's what the numerator factors into. And let's see, the denominator is going to have, let's pull a negative 4 out. So that leaves me with positive x squared, positive 4x, positive 3. Alright, and then that'll factor, the denominator will factor one more time. So we're going to have x plus 3, x minus 2, and we get negative 4 times. This will factor to x plus 3, x plus 1. So again, we have a common factor, x plus 3. So that means there's going to be a hole when x equals negative 3. And we'll see that in the graph when we get there. So I have found my hole at x equals negative 3. Now let's go ahead and find the x-intercept first, which is zeros of the numerator. So the only one I have to really worry about is positive 2. So the only one I have to worry about is positive 2. So x-intercept, x minus 2 equals 0. So the only time I'm going to cross the x-axis is when x equals positive 2. So that's x-intercept, x equals 2. To find the y-intercept, remember that's just the 0. So I plug 0 in for x. Whatever I get back is the y-intercept. So y-intercept, let x equals 0. And that gives me, so if I let x equals 0, I really only have to get 0 minus 2 over negative 4 times 0 plus 1. Right, so I just plugged it in here. Right, because I'm not worried about plugging it all in here. I've canceled those common factors. So I plug a 0 into the numerator for x, plug a 0 in the denominator for x. That gives me negative 2 over negative 4, which is a positive 1/2. So that means it's going to cross my y-axis at 1/2. So again, this is my x0, and my y-intercept will be the point 0, 1/2. So we'll find those on the graph, and actually I can show them to you right now. So it crosses, you can kind of see here, but our box is covering up. It crosses here at y equals 1/2. You can see that obviously the line is going right through there. There's 1, so that's 1/2. And then it crosses here at x equals positive 2. So those are the only x and y intercepts. That's the only time the graph will cross the x and y intercept. So we found the intercepts. Next thing we have to do is we have to, and I'm going to move this down. Maybe. So those are our x-intercepts. But now we have to find the asymptotes. So let's first find the vertical asymptote. So 0 is of the denominator. So again, all I have to worry about is negative 4, x plus 1 equals 0. Well, negative 4 does not equal 0, so it's definitely not a vertical asymptote. But x plus 1, if I want to get that equal to 0, again, my vertical asymptote is just x equals negative 1. So that line, when x equals negative 1, is also going to be a vertical asymptote, so my graph will never cross that. And then, let's see, to find the horizontal, I look here, and okay, my leading, or my largest degree of the numerator is 2, the largest degree of the denominator is 2, so then we just take the ratio of the leading coefficients. So the leading coefficient in my numerator is 1. The leading coefficient in my denominator, right, I can write a 1 there. Leading coefficient in my denominator is negative 4. So that means my horizontal asymptote is the line y equals negative 1/4. So it's just that line when y equals negative 1/4. So we found the intercepts, x and y. I showed you those. Now let's see what the vertical and horizontal asymptotes look like. So we found the vertical to be x equals negative 1, right? That checks. It's not going to cross x equals negative 1. This will go on to negative infinity, but never cross x equals negative 1. This will go on to positive infinity, never cross the line x equals negative 1. And also, this line will go on, all my x values towards negative infinity, but never cross the line y equals negative 1/4. And this one will go on to x equals positive infinity, but never cross the line y equals negative 1/4. So here we found the intercepts, we found the asymptotes, and in the next lesson we can see how we can actually sketch these graphs. Also, we found, since they had a common factor, that when x equals negative 3, it's undefined at that point. So go ahead, try the example problems that come along, that accompany this PowerPoint. And make sure you're checking back with the chart, both charts. Right, so this chart will break down sketching the graph. We just covered basically 1 through 4 today. We'll do 5 in the next lesson. And then make sure you're referring to this when you're doing your horizontal asymptotes, and just look at the largest degree in the numerator and denominator. So bring any questions you have with you to class tomorrow.